Hi, this is Charles, and I'm here to show you the current project I'm working on. It's a one-time interpreter for an old program called TAS. TAS 5 is the version I'm working with, and TAS stands for the Accounting Solution, I believe. It's an accounting language used for writing accounting software. My dilemma is that I have 16-bit applications with this software, but I can't put them on new servers. It means I'm stuck with anything very old. It's 2003 servers, 2000 servers, stuff like that. And I need to move my machines over to something 64-bit with, say, 32 or 64 gigs of RAM. To do that, I'm going to have to either rewrite all the applications or come up with a new interpreter. The new interpreter seems to be the best way. So what I have right here is the hex dump of a run file, and a run file is the tokenized bytecode of the source code that is written in this language. The way TAS works is it takes the regular source code that's human readable and typable, and it tokenizes it into individual integers and bytes, chops it up into pages, and then spits it out into this old school DOS format, back when memory was paged instead of large continuous blocks. There's really no compression or anything like that here, and you can see from the top, from here to here, the first 80. And when I'm speaking 80, it's hex bytes. This is a header, and these are byte, 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 byte. So word. So double word. So this double word right here is the location of one header. Here's another double word. Here's another location. Here's another location. Here's another location, and so on. It took a while to figure this out. So the first part of the file is the actual header. The second part of the file are the databases that are accessed. So there's two databases accessed in this one particular file. Down here is the spec code, which gives me debug information, address information, length and width of the actual code that is to follow later. So this is basically a hash lookup table. And right around here is the beginning of some static code block, which is basically a data block. Whenever there's an assignment, y equals 1 or y equals a string literal or something like that. Following that is the actual code, which is tokenized, and it's basically command and then values. It's like 54 and then a bunch of values, and you have to kind of figure out what equals what. After all of that fun stuff, you get a jump block, which is a location of go to and go sub labels. So it tells you the addresses and where the jumps will be located. So when a jump is actually set in a command, it's actually saying jump 1, which would be index 1, and then you go look up index 1. It gives you the address of where you will jump to in the actual code. Following that is some debugging information, and then the variables. The variables, some are created inline by the compiler because there are arrays in the application, but technically the way it works is there aren't. So it does some fancy stuff, but the user for a programming purpose never sees it, so it doesn't matter. But to run it, obviously, you need to implement it. These are the actual variables in the code. They're 48 bytes wide. It gives me the width, the length, so to speak, the depth, how many in an array, so to speak, how many decimal places, all of that stuff. From all of this, I'm able to or at least I am partially able to reconstruct the source code. I chose this way instead of interpreting the source code directly, because there's so many includes. I would have to test for the validity of everything, and I don't want to write a source checker to check the validity of the TAS code, if it's broke, if it's not broke. I would rather work with known good data, and also functions require different amounts of variables at different times. So this gives me exact positioning for everything, so I can build things in an exact way, and so they can perform exactly the way it should. I've got different classes for separating the different blocks of code. or data, the hex data in the run file. Each one of these classes, when passed a binary block, they will decode that area, and then I use patterns that I've developed for each function that you can see here, and this lets me decode and display the data. Now if I run the application and grab a run file, I can see here's the actual header. I've kind of gave myself a text output. On the bottom is the source. This right here is showing all the variables I pulled from the run file. It's not fully fleshed out, but the idea is there. All of the commands are here. The commands are very well done, but the arguments are what I'm working on now. Because there's a lot of pointers and jumping and space constriction, a lot of the expressions and evaluations are actually stored inside of string areas in the data area. And so I'm actually right now in the process of copying all of those and expanding them into the function area, into the code area, so that it can just be read the way it would normally be read instead of all that jumping around. Here is, say, the spec code. It gives me there's a bunch of data there and tells me where everything is. But this is my decoded version of everything, the hex version before it's reinterpreted. This is what I use to decode everything. And you can see here all the commands I've figured out. They have different. Each command requires a different length of data. There are different patterns in the data. A lot of it is addressing. Some of it's commands, some of it's block areas. This right here is how I decoded all the variables. And the idea behind all of this is so that I can interpret the run files, port them to a new language, and here's the benefit. They can just run through this application and you don't have to do anything and you continue writing in TAS, or you convert them and you don't use this program ever again, and then you begin programming in the new language with the TAS wrapper. Now the advantage on that is you're in a new language, you no longer need TAS, and then you can just use the wrapper as needed. And then if you want to start deleting or backing out or changing things to work in a more logical thought process, you can kind of just get away from the TAS functions and start building your own. It just depends on how you feel about your coding process. Obviously, it has to do with how much it costs to do all of this and the speed to get this done. And this is where I'm going. And this is all just so I can move my software to 64-bit servers, because right now I have 20 servers that run this stuff, and I want to get rid of them. Yeah, thank you guys.